Okay, for today, I want to start with the tennis ball lab. I hope by now you know that this is a really important equation, y equals negative 4.9. I'm using t, but what other letter could you use there? X squared. That's the beginning of the equation. And what does that have to do with again? Gravitational constant. And if we're on Earth, that's the number in meters. And then if we use something else, it could be like on a different planet. Is there different gravitational pulls? Absolutely. One thing that scientists have just recently investigated is there is some celestial thing just outside of our our planetary system that they think could be another planet, or a guy just theorized there could be a micro black hole that's really close to our solar system, which would be very interesting. Micro meaning a very small black hole, not like the giant ones that devour whole solar systems. But anyway, I thought that was interesting, that there might be a black hole, because they can't see it, and they're like, why is there these weird gravitational readings? There's something there, and then so they thought it was a planet that they just couldn't see, but now they're thinking maybe it's a black hole. All right, what else is like a black hole? It's coming up later this lesson. I could tie it in two places. All right, so the gravitational constant here, the gravitational constant in a black hole is quite different. Super high gravity. Anyway, what's coming next? What's this thing? VT, the velocity. And do you know the velocity you threw the ball at? No, but you can figure it out. And how would you figure it out? Well, that's the whole key to the lab. And if I just say, oh, you just stick this in and stick that in and then you solve, I can't tell you that. Because you'd have to know what to stick in where, but you should be able to figure that out. You can do this. This is not like rocket science. All right, one more thing. Let's say a kid is convinced that they have the right last number here. And you are looking at it going, no, that can't be right. Do you think he's right or not right? Can't be right. Why not? Yeah, unless he dug a hole in the ground and started underground, throwing it 1.2 meters from underground. That can't be right. So how about I put it this? Yes, that could be right. And I, on the board today, have this, and I want you to come up at some point during the hour, during the work time, or tomorrow, and you're going to have analyzed your video. You're going to have looked at your own video that you made of you throwing the ball, okay? And if you released like right here, then you'd be a 1.9. If you released underhand maybe and we're right here, it might be like 1.6. Totally depends on you. I've got it all the way from 0.9 all the way up to 2.0. Anybody that released way higher than their head, if you come up here, I can measure it for you. The worst case scenario is maybe a 2.1 or a 2.2. Okay, so that's how you get this number. And then, don't you have the time? Yeah, you have the time. But it's not quite as simple as how long was the video you recorded, right? You got to look at when you released, and then when it hit the ground. And one more thing about when it hit the ground. When you're scrubbing through that video, you very likely did not even catch the moment that it hit the ground. Why didn't you catch the moment that you hit the ground? You're recording all the time. Frames per second. How many frames per second does your iPad record in? About 30 frames per second. So it's kind of like a lottery. Did you happen to have your camera take a picture at the exact second? I know you're thinking, I'm filming. Of course it took a picture. No, when you're recording, it's actually just taking a whole bunch of little pictures. It's taking 30 in 1 second. Okay, and did it happen to catch the second that the ball hit the ground? If so, you'd see like a deformed ball kind of squished because it's touching the concrete. You know what I'm saying? It's pretty tough to tell if you ever hit it exactly. Now, for most of you, in last hour, nobody could find a shot of the ball actually touching the ground. They had shots of the ball right before the ground and shots of the ball right after the ground, but nobody had it hitting the ground. Take a second right now. Everybody look at your video. See if you caught the actual, not second, but like 1/10 of a second where the ball hit the ground. Anybody got one where they can see the ball actually like squishing into the ground a little bit? Yep, there's one. That's awesome. Now it's just luck. It's not like, ooh, I timed that perfectly, right? Yep, yours is definitely mushing into the ground. I got 2 people. Looks like the rest of you were just not lucky enough that the camera took the picture at the exact right second to catch the strike of the ground. So what do? Just get as close as you can, and that's good enough. And look at the time signature there. And of course, you're going to subtract it from, or the other way around, the time that you released the ball, right? So the second that it leaves your fingertips, all the way to the second it hits the ground, and both of those might have to be estimated a tiny bit. You know what I mean? Because of the 30 frames per second thing. All right, so in the end though, let's say that you released at 1.2, it hits the ground at 2.3, then the air ball was in the air for 1.1 seconds. See what I'm saying? Well, if I'm actually showing this, I would write the 2.3 minus the 1.2 equals 1.1 seconds. And that's how I would show my work. What section does that go in? Calculations, yes. I would say the procedure section until last, when you kind of sum up, here's what I did. I threw the ball in the air and recorded it. Number 2, I looked through the video and I figured out when I released and when everything. And then I subtract these 2 numbers. And then I stuck that into the equation, right? Yeah, you do stick that in the equation for t. And the thing that a lot of you guys aren't processing is you know more than just the time. Then you'll be able to figure out the velocity. All right, and again, you need to struggle with this. You need to see this in the real world. And I know some of you are like, oh, obviously, you just have to put this there. Don't just blab it to everybody. Okay, if somebody comes up and asks you for help, if you want to help try to explain to them, you can. Now, once you get the velocity, then you pretty much can do everything. All right, one last thought. Let's say I did figure out that my equation, when I solved it for 0, looked like this. Let's say I got an equation like this. How do you solve that anyway? Well, it certainly isn't going to be able to be factored, right? So what's the follow-up to if you can factor it? You should. If you can't factor it, you use the quadratic. All right, and that'll solve that. Now, one more thing that a lot of times people forget, there is a third way. And I mentioned that a lot of people were going to forget this way. And it's not the factoring thing. That does solve a lot of our problems. But what if you can't factor it and you don't want to use the quadratic? Is there another way to solve that? Graphing. Yes. How would you solve it by graphing?
Type it into your calculator.
So you type in y equals that, and then what? You see what? Where it touches x. Where it touches y equals 0. Think about that. You're really solving this, and you're seeing where they touch. You get what I'm saying? All right. So I have a negative on the beginning of that equation, so it would look something like this, and then the root's there, and there's another root over here. In the real world, you ignore that one, because that one's extraneous, because you didn't have a negative time where the ball was on the ground. Okay. And you do have a correct, not extraneous answer over there. Okay, so your assignment then is use graphing. You don't have to use graphing. Use the quadratic. Quadratic's a great formula as long as you set it equals 0. And you got to do something to eventually figure out your velocity. And then you'll be able to tell how high it went. What was that formula again for how high a parabola went? This spot here? Yeah, x equals negative b over 2a. In other words, that just tells you the time that the ball went that high. X is the time, right? So that'll tell you the time the ball went that high. Once you know the time, you can stick that back in the equation. All right. Okay, and then there is a question in the lab, and it says, what if you went up on the roof and you threw the ball off? Like I said before, that's assuming that you're throwing it off of the roof and you're going to have it land in the parking lot. And so it's still going to be when the ball hits the parking lot. Shouldn't it take a little longer to hit the parking lot if you threw it at the same speed? You threw at the same speed. It should take a little longer to hit the parking lot. I know. Not a lot longer, but a little longer to hit the parking lot. Because it's got further to fall. It doesn't just have to fall back to your foot level, right? Because you're up on the roof. So it's going to fall further. So, but do you get it's moving pretty fast by that point? So when it goes past your feet, when it would have hit the ground before, it only has to go from there down to the ground. So it's surprisingly not much difference in how much time it's in the air. All right. Some thoughts on the grading of this lab. Remember that procedure is part of it. That's where you say in words what you did. Calculations is where you show how you solved your equations. What if you use a calculator? Then make a little sketch of what the calculator screen showed. That's how you could show your work. Another thing it says in the lab write-ups is it's great if you can get a picture. Well, you happen to have a video. But don't post the video in the lab. That'd be monstrous and make your file super big and hard to like submit and stuff. So just take a picture. Why don't you just take a screenshot of you throwing the ball in the air? That would be cool. Stick that in the lab. You try and impress the person who's grading it. And that's one of the things that I'm going to, to remind people that I encouraged you to stick in a picture. How about the labels? That's a big deal. You got to remember to label things. How about the math reflections? Can I just put in one of those? No, it says 3. Okay, other things I grade for a lot. Title on the sketch. Got to make sure that you actually have the conclusion, has the conclusion in it. Conclusion should be the answers to the questions that were asked in the first place. And a lot of people are like, but the answers are up there. No, you're supposed to repeat the answers. I don't need to see show all the work, but reiterate what the answer to the question is in the conclusion. All right, I'm expecting that because I've reminded you of all that stuff ahead of time, you're probably going to do better on these labs. So remember, this isn't due for not just 1 week. It's due a week and a day from now, just because we have so many days off, with the long weekend and stuff. Okay? All right, so next up is some review for the test that you're going to be taking, your next test. It did have solving or telling whether something like this is even or odd or neither. Would you please take a moment and prove this is either even or odd or neither? And then we're going to review some other stuff. I'll pause for a second while you give this one a try. Okay, so I'm now going to put in f of negative x. So f of negative x, I'm putting in a parenthesis here. Okay, now I'm going to switch pen styles and go down a notch in pen. Just see if this is better or worse. Next is f negative x is equal to negative x to the third. And since that one's getting squared, I'm going to say it's positive 3x plus 1. Next. Oh wait, I've got it simplified down enough I can determine at this point. Is that exactly the same as that? That is not the same thing, and therefore it is not even. Next, I'm going to factor out a negative 1. And I have x to the third minus 3x minus 1. And then that doesn't look like this either. Because if it did, I would replace this with f of x, and I would have been able to say f of negative x equals negative 1 f of x. If these had been the same. But they're not the same. So I'd say not equal to that, and therefore not odd. Therefore neither. Yes?
Shouldn't it be 3x squared?
Uh-oh.
Just 3x
Double checking.
on both of
Squared, you are correct. Thank you. Thank you. And let me see if that affects it. I think it still will be false, or it still will be not odd and therefore neither. Do you agree with that?
Yeah.
Okay. Thank you for catching the missing squared. All right. So there's a proof. we've done enough of those now where if you really need a review of that, I've got a video that talked about it for the first time that went over it in detail. And we've reviewed it a few times, so look at the last couple videos. Okay, next, this was one of the harder things. Imagine for a moment that I have a function, looks like this. And then I ask you to take and change it so that you have f of absolute value of x. There's three ways to do this. You can take 1 over the function, you can absolute value the inside, you can absolute value the outside. This is kind of the medium one. This is not easy. The easy one is, I'll do the easy one in light green. The easy one's where you go like this. Okay, for that blue one, I'm absolute valuing the x's, so where the x's are negative, that's these spots here is where the x's were negative. Anything over there, that part has to go away. Why? Because I absolute valued it and they're positive now. But a lot of people think that means it flips over to the other side over here. It does not. Because if it did, then it would make, if I kind of roughly sketch that on here, it would have a graph on top of another graph. That wouldn't pass the vertical line test. So it's not that. When it does go away, what do you have left? Well, basically you have this function left. And then it gets copied over from the right side to the left side. Why? Because when you put in -2, for instance, it thinks you put in +2, goes up, gets the answer for that, and puts it in. So it gets deceived into thinking that it was fed a +2. And so it grabs it from here, and your answers just get remapped over to this left side. All right. Now I'll do the kind where you absolute value around the outside. And that one is my starting function. On that one, whatever was negative y's have to change to positive. So then that's going to look like this. Raise your hand if you had that one right. Okay, and then the last kind to review is 1 over f of x. Anybody remember what this is called? There's inverse and there's reciprocal. Which one is this? This is a reciprocal. All right, so a reciprocal function takes 1 over the f of x. What did I just remind you again? F of x is really the same as what? Y. So when I say 1 over f of x, that's like saying 1 over the y. So on this first one I'm going to do, I'm going to remind you that if I give you actual points on it, it's actually super simple. You just figure out what 1 over those points is, and you graph that. So if this is at -2, 0, this is at -1, -1, that spot there, let's say that's at 0, 1.5. Let's call that 1, 1. Let's call that 2, 0. Let's call this spot 3, -3. And last but not least, that spot, let's call it 5, -4. Yes?
On the second point, should it be -1, 1?
You are correct. Thank you. Dang, you're much more careful than I am today. I'm sure other people were thinking it, but please be bold and raise your hand like he did. Save a lot of people erasing marks. Okay. Now, how do I graph its reciprocal? Really, you're changing all the y values. The x values stay the same. So it's negative 2 comma something. Negative 1 comma something. 0 comma something. 1 comma something. 2 comma something. 3 comma something. And 5 comma something. But wait. When I put 1 over 0, I don't get anything. You're right. So that's why there's an asymptote right there. Raise your hand if you had an asymptote right there. Okay, good. So you knew what to do when there was 1 over 0. There's another place that happens. And then I'll do the graph in red here. Remember me saying there was another thing in math that was kind of like gravity? That was a funny noise in the hall, yes. I wonder really what caused that. Okay. What happens really is the function gets closer and closer to that asymptote. It gets drawn to it. It'll never get drawn up to it towards the x-axis, though, because you can't cross that x-axis. When you cross that x-axis, your y's are going from negative to positive, and that'll never happen just because you put 1 over it. So if I'm going to get closer and closer to this thing, it'll have to be closer and closer as it moves away from the x-axis. Now, would it actually touch at 3, negative 3? No, it wouldn't. Where would it touch? Whenever it hit 1, I'm going to say that it hit 1 like right, oh wait, like right there is where I'm going to say it hit negative 1. And that's important because at that exact moment, 1 over the y value of 1 would keep it the same. So it has to go through there, go in this direction, and then kind of level out like that. Want proof? I take this point, and I say my new point would be 5 comma negative, and then put 1 over it, negative 1/4. That's like right here. This point that used to be at 3 comma negative 3, it'll be at 3 comma negative 1/3. Okay, now I'm going to assume you and last hour are pretty similarly smart, and therefore probably not all of you got that right the first time. So I'm going to do one more practice problem on this because a lot of people could use some help. I think it's the hardest thing on the test. We math teachers even like take a while to do these because it's kind of counterintuitive and it's like it's not easy. All right, so let's do one more of that kind. Let's have it start off with a function that looks a little different than some of the past ones. Now, to make life somewhat easy, I'm going to tell you where the spots are that it hits 1. I'm going to determine for us that these are the spots where the function hit 1 or negative 1. Why are those important? Because it's not the asymptotes go there, but something else happens there. And then another thing that's important is where it hits 0. I can bet you can tell there's 3 spots where it hits 0. If you do the right thing when it hits 0 and when it hits 1, then it's not that bad. First thing I would do, put in the asymptotes. All right, I'm going to pause for a second while you give this one a try. Okay, first you got asymptotes running through here, here, and here. Next, I'm going to change this to blue for the actual lines. I'm going to say, remember how it has to go through the same point here? Why does it have to go through that same point? Because the y value is negative 1, and when you put 1 over that, it's the same. Then it gets closer and closer. Why couldn't it have gone up right there? Because then, as the asymptote got closer and closer, it would also have to force to be crossed over this line, which it couldn't, because negative values of y can't change to positive values of y just because you put 1 over it. All right, so it must be going down this way, and up this way, and up that way. And then this last part. A lot of people will get this last part wrong. Oh, I guess there's a little stubby end over here too. Should handle that. When this got really small over here, my inverse of that gets really big. So again, it has to get closer and closer to the asymptote, going that way, and ends right there. This one goes through here for sure. I'm thinking it through. If it's going to get drawn to the asymptote, just like drawn into a black hole, it's going to get drawn this way. It has to go that way. It can't go up that way, or it'd head towards crossing the x-axis, which it can't. And then, whatever this is, it's not infinity. Okay, so therefore, I'm going to stop right there and say that's, let's say this had been like -10. Well, this would be -1/10. It'd just be really close to 0, but not 0. There we go. Why didn't I just say it kept going like this? Well, because I didn't say that had an arrow on it. So I stopped it right above it. Okay, those are the toughest kind. And we've had more than one chance to practice it. So tomorrow's lab day. Then you come back on Monday after the long weekend, and you'll probably have forgotten a lot of this, but then I'll review everything on Monday. Test Tuesday. Lab due officially Wednesday. Mostly just because why make the lab due before your test when you should really be focusing on the test until then. And the day of the test, there's no other homework, so you may as well do it that night. So I know you could I could make the lab due tomorrow, but you mostly aren't going to be here. Well, some of you aren't going to be here tomorrow, etc. So, all right. And by the way, this lab is being done in preparation for a unit that's more about quadratics. So I know this lab isn't tying in perfectly to what we're doing in class, although we do have quadratics in this unit. There's even more of them in the next unit. So this lab is kind of going to tie in even better to what we do next. Okay, that's all I have for you for today.